after we just glue in the thing from the last time. TDD, test during development. You start from a test, you make it pass, you refactor. That's basically a way to build software. Okay, you write test, you use the test to write the software. Basically, it looks like that. You write a test and you see the red lines there, and the red lines, it's because it doesn't compile. And then you add the code to pass the test. Red lines disappear. You add logic, but that looks like this because the computer generated it, and then it passes. It's green, but then we don't like I and J, and then we change those to better parameter names. That's the refactoring part. And purple is not really something that everybody agrees on, but it's a nice color. So that's basically TDD. And as you can see, it's very simple. All the examples that you see in TDD, something like that, then everybody will try to do it, and most of them will succeed, maybe. Well, TDDing and APIs is kind of a completely different beast. And there are reasons because it's very hard. TDD has a lot of premises in it that don't appear when you're trying to test first an API. First of all, TDD is basically for logical code, not for big infrastructural code. So when you're trying to TDD an API, we'll need setup, we'll need a server, we'll need examples I'm going to show you today. You'll see I'm going to use Spring. We'll need to load Spring. Make sure that the server is running in order for us to run the tests, and test for the first test. TDD, and when I coach people, I say that when you're doing TDD, usually it should be up to 10 minutes, 15 minutes tops until you pass a test, and then move on to the next one. With API tests, it's usually not that short. Sometimes it takes days to actually pass a test. And that's a problem because TDD is kind of creating this momentum of I'm going to move to the next one and move to the next one. And I see the greens popping up, so I feel good about myself. It doesn't happen with APIs. Systems are bigger. TDD works with application logic. It uses semantics from the application, the data. There's a lot of framework code and test code in API tests. And that kind of removes us from the focus that we talked earlier about. We're trying to focus on passing the test, but basically on what makes the application work. And there's a lot of background noise about it. We have a lot of dependencies. Some of it is the frameworks we're using, some of them dependencies that we are calling. It could be a database, it could be other services. And we want to pass a test. We need all of them in, and that's hard. And finally, what we'll probably think about the first thing, it's going to take a lot of time to run. If you, with the first test, maybe not so much, 100 tests, oh yeah. So the feedback cycles starting too long. So what I'm going to show you today I decided I'm going to show you an example for that. And I'm going to show you the examples with every step I took. It's not like I'm showing you the end result. I'm not going to do the typing, that's too boring, but I'm going to show you a step-by-step, a 20-step recipe. This is where you actually run away, about how it's done. So what to expect? What do we need to expect when we're trying to take this kind of project with us? It's not going to be as smooth as real TDD. If you try TDD and you know how smooth that is, not a lot, it's not going to be even as smooth as that. So there are going to be all kind of stumbling blocks we're going to stumble upon. it's going to be like a couple of runs until we get it right. The forward, there's going to be a lot of forward and backward motion to feel our way, and that's okay. We're going to continue refactoring, and sometimes we're going to refactor when it's not green. I know. Well, there's a problem there, but we'll try to do that. And the reason we'll try to do it is because if you remember, the API part may not pass until like a day. Does that mean that we don't refactor? Of course, we're going to refactor. So we're going to take some kind of assumptions that and try to do as much as we can, not to break anything, but refactoring is going to be part of the journey. And after that, there's something that we'll need to think about, is that we might need more tests without adding code. I'll show you that at the end. So we have a couple of rules today in our TDD club. And it starts with this diagram. So diagram. What is this diagram? It's called hexagonal architecture. It's something that we've known about since I think the 80s, if not earlier. The name ports and adapters came around the 90s, around the people who were doing extreme programming, and Alistair Coburn, of course, the agile people who did not invent the word agile yet, but this was there. Hexagonal architecture basically means that we kind of create a business logic, what is important to us, and everything that we talked with, whether it's input or output, see both sides, are going through ports or adapters. This is very critical to our success of doing TDD, because in TDD we're trying to focus on the logic. If we're trying to talk to a service that requires like 100 database connectivity and service connectivity on authorization lines of code, it will not work. So we'll need adapters to that. So we have a couple of design rules. First of all, we use adapters for anything that we can't control. Services, database, file system, Spring in our example, they're probably not going to be an adapter. We can't use an adapter for everything, but what we can, we'll use an adapter. These adapters have to be very thin in terms of logic. They should be almost empty of logic. Why is that? Because if they have logic, that means that we want to try to develop them with TDD, but we don't want to talk to a database or the services as we're doing that. So we're going to assume that the adapters almost have no logic in them, just like data transformation, stuff like that. If possible, push that into the application logic. If not, we'll have to develop the adapters with TDD as well, or not, if we decide to. We try to use application-specific data. Everyone has written API and passing data around between the client and the server knows this. Frameworks today are very easy to it's very easy to take it and serialize it to JSON back and forth. And we'd like to use data objects and not primitives as much as possible. They're more extensible, and we're trying to extend, because we're going to use TDD, to incrementally add more fields, logics, and so on. We need to take small steps. That's the basis of TDD. It's also for TDD in an API. Without small step, we can't be able to focus on what we want to achieve. We're going to spread ourselves, and we're going to make a lot of mistakes. I know, I did. I'll show you some of them. We have to refactor for readability all the time. This kind of goes with the last point I made. It helps us keep focus, and we're trying to not leave parts of the code, because we're going to jump between those without the need to come back and try to decipher what we actually meant. So refactoring for readability is something that we're doing all the time. We'll try to abstract framework code. I'll do that from the beginning. You'll see that as much as possible. Again, this framework code, regardless if it's in code in the application itself or in the tests, it's noise for us. Yes, we need it in order to run, but we don't need it in order to understand. So the abstraction helps there. And we'll try to delay framework code integration as much as we can. I'll talk about it here as well in terms of Spring. And we'll try to not do this as we go. We try to delay that as much as we can. Why? The more we introduce framework code in, it will create problems that we didn't anticipate. It will stop us in the cycles. It will create things that integration tests are failing on, and we don't like it in our TDD cycle. So what we're going to develop is an application called the Navigator. And I know Dora is Explorer. It is the Explorer, but it's a Navigator. What does the Navigator do? The user can set a destination. We can drive there, and the user can ask the distance between the current location and the destination, and he expects the answer to be in kilometers. That's the part of logic we're going to do. So we have a plan. How do we do that? So here's the game, the rules of the game. We're pretty much independent about what we're going to design, how the APIs look like, what we're going to transfer, and so on. And I'll go through the thinking that I did through the steps here. I wanted to introduce a dependency, and that would be the distance service that will tell us the distance between two cities. And so that's the dependency we have. And we're going to build in Java and Spring, because that's how I decided consulting with Stone Code. So in our application, the Navigator in blue is the logic. There's the Navigator controller on the left, which talks to the test, and we'll talk to the UI in another webinar, maybe. And there's going to be a distance provider. Both are adapters, which is going to talk to the distance service. And we're going to start now. So when you have the link to my source code, you'll see all this. So this is a step-by-step of what I'm going to go with you. And I started with an empty project. This is a Spring Boot project. So I went to a Spring Initializer and created an empty one. It's a Maven project. And basically, when it creates the project, it didn't have any code in it, which is cool. That's how I like it. If you haven't used Spring Initializer, use it when you're on your next one, because it creates a lot of cool things for you. And this empty test is one of them, because it kind of help you see how things are going in terms. It looks like it doesn't have any code, but it loads the Spring context. Obviously, what I'm going to show you today, I haven't mentioned it, is not just a Spring thing. I'm using Spring for the example, but APIs you can do in whatever language and technology that you can. So I'm starting off from an empty project. The first thing I did was create API tests. And you'll see these API tests, which at the beginning didn't really compile, are written in English. So the first test is checking that if I'm checking the distance between where I am and where I am, it will be 0. And the second one is checking that if I started in New York and checked the distance to Los Angeles, and then I drove to Dallas and checked the distance again, the distance was reduced. This is what's here. Okay, these are two API tests. readable tests. Obviously, they don't do a lot. You don't see the red lines here because I created stubs for them here. But obviously, they don't do anything because currently what I have is this code plus the location. The location class that I created here basically has a constructor, doesn't have any code in it. It's like TDD, what at the API level. Again, what's important here is that I understand where I'm going and no Spring Boot test things going on here. What I'm going to do next, step number 2, is fill in the blank. So tests remain the same, but I have all the test framework code under here. It requires a mock MVC for Spring Boot and calling post. I already specified here the URLs. Remember, my requirement says yeah, I'm free to design whatever I want. So I decided the URLs look like this. So I decided that it's a post here and it's a post for set starting point. Drive to, I decided it's going to be a set starting point as well, because I'm testing the application. I'm just going to like move or reset a starting point. So that we did the same thing. And I have methods here for, I had designed a getter, which has a distance. It has to be serialized from JSON, and distance has a method called in kilometer, because I decided one of the things that I decided as a constraint was the distance provider will provide things in miles. And that's basically it. I have some more serializing thing here. So now I have these APIs. I created an empty controller in the test that doesn't look like a controller because I need to set it up for the Spring Boot. Location, I needed to do this, added a constructor for serialization, because otherwise it will have problems. I discovered this on the way, by the way. And I have a distance object, and currently, because distance is only a method, I put in -1, so I'll remember to fail on my tests. Okay, everything in the test project. Cool, but not as much as we know it. So the next step was to move distance, location, and navigation API to the production level, which is here. Basically just moving things around. If you look and you know Java, you know that this won't work as a controller. And that's okay. You need an annotation for to tell it it's a controller and stuff like that. But at this point, basically, we're just moving code around. And if you run the tests, what will happen is that we'll get a 404, because we're trying to access URLs that are not there, which is okay. It's okay for us now. What else happened is that on step 4, I'm failing on URLs, so I'm going to add this code that will load the controller as a controller. I'll talk about the URL in a minute, set up a root URL and call the APIs so I don't get a 404. What is this 4s and 5s that you're going to see from here on? This is not something that you need to do in TDD or TDD and API, but because I stuck all these examples in different steps in one project, Spring doesn't like that. So I needed to rename them without making too much noise. This would be easier. But you can ignore that. There's going to be, in your example, like one Navigator controller and one API only. So that's out of the way. So now, if we run this, basically we'll get a 500 problem because distance could not be serialized, I discovered. Why is that? Well, I needed to add content type application JSON. Oh, Okay, so this is the thing I was talking about, where I'm failing not because of the logic, but because I'm writing tests wrong or not enough good. So it's the stumbling part. But after that, after adding that, we're actually failing on logic, which is what we wanted. Because now that these tests are failing on the asserts, not on the API calls, we can move on to the next page. I'm going to move to number 5. And I'm close anything because that's going to start being very confusing. So navigation and the API tests are now going to remain like they were for a while. I am going to start writing unit tests now. And the first test I wrote, and that is some of the things I do sometimes in TDD, is I'm asking myself, okay, this is going to be a navigator, and this will be inside the logic. And I'm guessing if I call get distance from destination without setting a starting point, I'm going to get an exception. And that's cool. The only way to pass this test in TDD is obviously to have get distance from the destination, throwing not initialized exception. And that's cool. I have a passing test, but then I'm thinking, well, is this the test that I really want? Because if I do that, I can look at the well, I'm sorry, I'm stopping for a minute. If you have a question, put it in the Q&A session, please. I'll try to get it as much. I'm trying to keep the flow here, in the Q&A. Next. If I'm allowing it, and this is a design decision, to create a constructor and get distance from destination will throw an exception, why am I doing that? Why not create, why create this problem if I can not create it? So I went back to the test and changed that. So instead of throwing an exception when there's no starting point, I decided that we'll create the navigator with a starting point. No problem. Don't need to have an exception now. So this is a test, and get distance from destination now looks like this. I'm creating a distance object. Remember, it's very empty. I set a value to it and I return it. And that's basically it. It passes the test, which is very cool. Now, number 6. So number 6, I just, if you remember, distance returned -1. So I had to change from this to passing 0 in order for this to work. So in 7, which we actually pass it, this is where it gets confusing. I changed that to 0. Okay, so now I have a unit test that passes. Excellent. Then I added another test, another unit test. This one says 2,500 miles. I want to if the distance is 2,500 miles, which is the distance between New York City and Los Angeles, I want distance in kilometers to return for 4,000. Now, obviously, the logic is there. It's not there yet. I'm going to complete it, but now I see a problem because remember, I have to work with the distance provider. Okay, where do I get it in? I need to change stuff. If I need to change stuff, I need to change the navigator. Basically, what my thinking is I need to inject it into the navigator. I need to change the constructor. If I do that, I'm definitely going to break 2 tests. Not going to happen in my watch. So TDD. So instead of that, I commented out the second one that I wrote and changed the first one to have an injection of a distance provider. This is our adapter. And I changed the constructor signature and I'm passing it in. And distance provider at this point, the adapter, and completely empty. So the next step is to do a bit of refactoring. I have a passing test because the system provider doesn't do anything, and get distance from destination still returns an empty distance. I want to do a bit of refactoring because I can, because the test passes. So in refactoring, I'm going to if I go to Navigator, you see the get distance from destination has this code in it. Now, what I want is to move this code into my provider, because this is where it's going to be. So step 10 now. Test remains the same, but the Navigator now looks like this. I'm now calling the provider, and in the provider's get distance method, I just pushed in that code. So basically what I did is move the code into the provider as it should be. It's not the final provider, but currently it gets the distance as it should. Still, the test passes. Excellent. Now, I know that my unit test will not work forever with real providers, so I changed that once I have a signature to a mock. And I'm not going to go a lot into Mockito right now. This basically says that a method of a method of a method is still mocked and will return 0. Still works because now distance provider is mocked, and get distance will return 0. Excellent. So now what I have is one test, a unit test, that I'm basically pretty okay with how Navigator works and looks. And the behavior of returning 0 is done in the provider as we want it to be. And now we can switch back to this old test only in its current form. So this time I have a lot of code here that basically returns 2500. And hopefully when I put in the code, will pass the test. So this is the same as before. Operate this and give me the distance between New York and Los Angeles. And now the mocked value will be 2500. But this obviously fails because in kilometer, if you recall, still returns 0. So the next step, TDD, add the logic that passes the test. That's number 13 now. I'm trying to keep up with myself. So distance in number 13 will change that with the logic. I'm just in, it's not, I know it's not too complicated. It's multiplying the value with 1.6, but this represents logic, application logic that you would put in if you had logic. Because remember, this the blue thing in the diagram, this is it, times 1.6. Now I have a unit test that passes. So these two tests here pass. But as you can see, already this is kind of ugly. All this kind of thing just to, this like setting up the mock. So before I move on, I want to refactor that, refactor the test. So I create the mock in the setup method. Here we don't need to do anything with the first state, it will just return 0 because by default. And here I extracted the thing to create the mock and return to a readable form. Like I said, it's very important that we keep this readable all the time. 2 unit tests passing. What else? Well, if you recall, in our Navigator, so it works because the mocks return the get distance, right? Set destination is still empty. Set destination, I know I need it, but so far it didn't make any impact. How can I know that it makes an impact? TDD tells us, add a test. Oh, that's cool. So what kind of test will I need? Well, if you know about interaction testing, you know that if you're working with a mock, you probably want to say, well, if I'm controlling the mock, that's cool, but I want to see that I send the right parameters to the mock. So I'm going to write a test that tells me if I'm talking to the distance provider correctly. And that's number 15. So first two tests remain the same. The next one, the next test that I'm adding sets up a set starting point and destination, call set destination, get distance, and I'm using the regular mock from 0 because it doesn't interest me the return that was set up in another test. But I want to make sure that the distance service, the distance provider, the get distance method was called correctly with these parameters. Obviously, this is failing because get distance, not distance, the distance provider navigator, sorry. This is what interests me now. At this point, we'll call starting point with what I set up, but the same starting point that was set at the beginning. It didn't bother anything because it was a mock. But now it's going to fail because it's not, the second parameter is not the endpoint. So I need to add code for that. Excellent. So tests stay the same. And I'm going to look at the navigator, and you'll see that all I did was set up the endpoint, send it, and that passes the test. What I have now are 3 unit tests that tell me that the navigator works correctly in terms of its own logic and how it works with the provider. And that's very cool, because at this point, this is what I want from the navigator. What I need now to do is go back to the API test and pass them. If you ran this before, you'll see that the first test in the first API test actually passes. And that was because the distance that we're using returns 0. But that's not really passing the test. So what we want to do now is go backwards into the API tests and pass them. So for now, well, let me just close everything here. Unit tests are okay. Navigator, distance, and location and are okay. But now I want to go back, and I'm going to close everything here because this is already confusing, and pass the API test. So in order to do that, not going to touch the test right now, neither the unit tests or the API test unit tests stay the same from now on. What I do need is to make sure that this works now. So I add the code here. So distance, let me just, of course, you don't believe me. The Navigator controller up until now was kind of empty. So set destination and start point were empty. Get distance, we just created the distance and returned it. We now want to actually operate the Navigator logic. So this is the code we're adding. So set start point creates a distance provider right now and creates a navigator and calls it. And set destinations call set destination, and get distance called get distance from destination. That's cool. So that's just filling in the navigator. But now I need to use that correctly. So I'm actually needing to do some Spring stuff on the API end, because I want to inject the provider. So instead of just creating the new controller as is, I want to inject it through Spring, because I want it to run as a controller. It didn't run until now too much as that. So in order to do that, I'm creating a configuration in Spring called Navigator API test configuration. And basically what it does, I'm doing two things. First of all, I'm injecting the controller itself. I want it to load as a regular controller, and the distance provided because I want to inject it as a mock for the API tests. Makes sense. Only when I did this, I discovered a problem. Let's look at the controller. Remember, not this controller, the Navigator 817. Yeah. So you remember that I said that I'm using one navigator here, and I'm calling set destination with that. But if you recall, I can the starting point is kind of embedded here, and in my test, my API test, if you recall at the beginning, I said that both set start point and where was it? Drive to, both calling set start point. And that means, sorry, not that. And that's a problem because set start point currently doesn't it creates a new instance of the navigator. So it rewrites my old navigator. And that's a problem in the controller. That's a bug that the test caught. Excellent. I need to fix that. So how do I do that? So in number 19, I needed to, well, I had a problem. I had a design problem. The problem I decided to solve was that Navigator kind of starts with, okay, the problem is that the Navigator is created twice, which is okay, but if I need to use a single point of it, I need to actually separate it from the starting point, because otherwise I'll need to call the destination. If you recall, that's the first problem I was trying to solve with the exception. But now I discovered I needed to do that, and this is what I did. So how do I do that? I go back to the unit tests and change it there. So I'm jumping a bit further. Now Navigator goes back to having just one parameter, the distance provider in it, and I'm calling set starting point from it. I change the code without adding the exception, just to be able to work that. I changed this in all three tests, so I have 3 unit tests passing, and now I can go back to the final part of what I'm going to show you, where, so let's look at the tests. I'm injecting both a navigator with its distance provider, the mock, and I changed the navigation controller to auto wire both the distance provider and the navigator. So now the distance provider and the navigator are the same thing. And everything comes from Spring and talks to each other. And finally, I have things that I'm actually working. That was a long story. And I bet you're kind of feeling like this. Those who actually are still here. And I want to share with you what we got and what we still need to do. Okay, so let's go from the top. We have readable API test. That's very cool. Most people don't have those. Most people write API tests like a kvetch of framework code, and you need to read from that. And if you go back to one of the webinars I did before, you'll understand why I don't like those. But we started from readable API tests. And when we did that, we kept this thing going, the separation between readable code and framework code. Second, we have readable unit tests, which test the logic. we developed the unit test, the logic with the unit test in TDD fashion. We have architecture and logic that work. First of all, they work because our tests tell us they do. And the architecture, we kept it the principles of clean architecture, the hexagonal architecture, separating logic from the providers. We kept the controller, which is kind of a provider and adapter, also thin, calling into the navigator, and the navigator calling into a thin provider, and sometimes mocked. And we have the main workflows that work because our tests tell us that they do. What don't we have? First of all, what we started with it was discovered as a good idea, the exception handling. We'll probably need that, and we'll need to understand how to propagate that into the API. Second is we kind of created a distance provider, which is a placeholder, but we actually need to develop this thing that talks to the real service. We can do this separately and inject that into the application, which we didn't do that either. So the application currently doesn't have a distance provider to inject. That's okay. It's very easy to do, the distance provider that we do have. But the distance provider that we need to develop separately, it would be the layer that calls that service. Finally, and this is the final point I told you where what we might need to add tests that don't exist, although the code does exist, is that once we have the distance provider in place, the logic doesn't change, the controller doesn't change, but our API tests today talk to a mock. We might want an integrated test that talks end-to-end test that talks to the distance server as well. Now, this is a real test of real system that may break when the service is not available. That's okay. But we might want some of these tests as well. I think that's what I wanted to tell you, but there are a few principles that we went through that we always kept in mind, or I did when I did that. Small steps. Almost always do just when you decide you need to go backwards, when you need to move forward, do it a small step. Plus commit. I did a lot of commits. Why? Because even when the test is not running and I made a change, I want in a big system a place to come back to, a place to revert. If I try to change code in a lot of places, chances I won't remember what I did where. And I needed a safe place to say, well, this point all unit tests are working. At this point, one test is failing, and I need these commits. It's not about Ronaldo. It's about being focused and not being messy. Don't spread yourself. The small steps are about being focused on what I want to do next. And if I want to pass the test, cool. If I want to refactor the test, cool. Very, very small steps, and this is what I'm focusing on. If I need to do something big, like the reverting the tests and changing the constructor, I'm not going to do everything. If I believe in myself, sure, I will believe in myself and be able to believe that I will not break anything, but everything will break. So focus on small things. And these are very small. And in TDD, we teach that we're doing very small things, very small steps. If you're doing a lot of dancing, if you don't, cha-cha-cha or cha-cha is a dance where you move backwards and forwards and forwards and backward. And this is what I did. It's not a cycle. It's not a TDD cycle. It's not moving forward all the time. Some of it is moving backwards. So, and that's the reality, but it's possible to do that. Because at the end, if you stick to the principles, it will work for you. Let's see if we have questions and write them and see. Do you find that you are tempted to repeat tests as API and unit level? Do you have general advice for choosing where to test a specific piece of logic? So these are two questions, very good questions, really. It's not a question of temptation. Some of it is really. If you still recall what I did, my first unit test was similar to the first unit test, the first API test. It makes sense that I will follow these steps because when I built this stuff from the beginning, it makes sense that the API will probably look like the unit. It doesn't have to. But as you saw, I made a decision that it doesn't have to look like this. Later, I discovered that that was the wrong decision. So the best advice I can give here is what I did, which is to try, because what we're doing in TDD, we're trying things until they look okay. Making the pass is one thing, but if they look okay, that is something that you have to live with, and therefore either you discover over time or you say, well, this was okay as well. Second is, do you have general advice for choosing where to test a specific piece of logic? Choosing where to test a specific piece of logic. I can't really tell. I can tell you this. The API tests look at the behavior of things. So obviously the first one checked that the distance between allocation and its allocation is 0. But the second one, it wasn't quantitative. It says that if you get close to somewhere, the distance will be lower. So that's a behavioral thing. It's not a logic thing. So I kept the logic thing to be the exact calculation to be at the unit level, and at the API level, I stayed at the behavioral stuff. Is it something that I will always do? I don't know. This is what I was thinking at the beginning, what kind of first test I'm going to do. And it made sense to me not to be exact. It made sense to me that as I will go forward and I'll work with a real service provider, the numbers may change, but the behavior will stay the same. So I try to keep the behavior at the API level and the exact calculation logic at the unit level, if that makes sense. Okay, so let's see another question. You said that test runtime was longer this way. Did that stop you from running the test? No, at this point, everything was running on my machine, which is okay, because if you know Spring a bit, what I was running is what Spring documenter is called Spring unit tests. It's not really a unit test. It runs the entire Spring, and it's going to be heavy if your computer is slow, but it does, using mock MVC, create its own local server and runs it there, which usually is a lot slower, a lot faster, because it doesn't raise the entire application. I will tell you that in a week, if I continue to develop that, it's going to impact me. And I will try to hack my way into running this in a more faster way if it didn't if it starts bothering me. I can tell you that I am allergic to runtime, so I try to notice when things are starting to bother me. When they do, I will probably stop running, or find or structure the tests in order to run just the ones I'm interested in, so not everything will run all the time. But yeah, this is a limitation we have to go through. If that's everything I have to show you today. It's a lot of technical stuff, as you probably saw, but this is a technical session. And you should be grateful that I didn't type everything. That will take like a whole day. But this is what real life looks like when you're starting from scratch. If you're starting to work inside a real application, it will take even longer cycles. Another question, there was a question, should we use constructor injection of services into the controller? Basically, it really depends on the technology stack that you're using. Spring allows you to inject whatever you want. I like to see things were happening. So Lombok, for example, creates an old constructor with all the fields, which kind of obstructs your view of what you're actually doing, which is not that good in TDD. So it really depends on you. So I use constructor injection in my examples where I try, as you saw, to not create problems, but as you managed to see, I created a problem. So constructor injection basically, if you're using that versus setting a field or versus auto wiring something, I see that as a design choice that doesn't impact too much. The only thing that does impact is that for the logic, I stayed away from injecting something springy. My logic remains platformless or frameworkless because this allows me to do the TDD quick cycles. Okay, will there be a recording? Yes, there will be a recording now that I even remember to press the record button and not just me retelling the story. So yeah, so I want to tell you thank you for coming today and staying till the end, those of you who managed to do that. If there are any questions, you come up in the middle of the night and you think about, oh, you should have done that. What you see on the screen right now is how you can contact me. Email, LinkedIn, Zing, Twitter, Telegram, probably something else. Write me, tell me I'm wrong, and we'll probably see you in the next webinar if this one didn't kill you. So thank you everyone for coming. And thanks for interacting with me in the chat. And for the people who won the books, congratulations. You will get in touch with you in the next few days for how to get them. Thank you and good night. Hey everyone, if you enjoyed this video, be sure to like, share and subscribe for more. Thanks for the support and remember, live long and test.